How does convection work in thermodynamics? Imagine a pot of water on the stove. As the water heats up, you might notice bubbles rising and swirling around. That's convection in action, a way heat moves through fluids like liquids and gases. When part of a fluid gets warm, its molecules gain energy and spread out. This causes the warm part to become less dense and lighter than the cooler surrounding fluid. Because of this density difference, the warm, lighter fluid rises, while the cooler, denser fluid sinks. This movement creates a continuous loop called a convection current, which helps transfer heat from one place to another. There are two main types of convection. First is natural convection, which happens because of buoyancy forces. When a fluid is heated, the warm part rises naturally, like how hot air rises above a heated surface. For example, when you boil water, the hot water near the bottom rises to the top while cooler water sinks down, forming a cycle. The second type is forced convection, which involves an external force moving the fluid. Think of a fan blowing air over a hot surface or a pump circulating water in a heating system. This external movement speeds up the heat transfer process. The speed of heat transfer by convection depends on a few key factors. The bigger the temperature difference between the surface and the fluid, the faster the heat moves. The size of the surface area involved also matters. Larger areas allow more heat to transfer at once. Another important factor is the convective heat transfer coefficient, which depends on the properties of the fluid and how it flows. This coefficient tells us how effectively heat is transferred. We can express the heat transfer rate with a simple formula. The heat transferred per second equals the convective heat transfer coefficient times the surface area times the temperature difference between the surface and the fluid. This helps engineers design systems like radiators, air conditioners, and heat exchangers to work efficiently. In nature, convection helps regulate the climate by moving warm air and ocean currents around the planet. In technology, it keeps our homes comfortable and cools electronic devices. Understanding how convection works in thermodynamics helps us control and improve these systems, making our lives better and more energy efficient.